Our next speaker, Mr. Vignesh Mariappan, Technical Sales Specialist at NFE Technologies, speaking on today's topic, using advanced spot imaging technologies for inspecting TKY joints. Over to you, Vignesh.
Thank you. Thanks, Melvin. Thanks for the whole team for having us here. We are speaking about ultrasonic technology, which is being used in the industry for quite a while now. It all started during the Second World War period, and ever since then, it has been growing. So in today's presentation, we are going to speak about one of the challenges which are still there when we speak about weld inspections, and which is TKY kind of joints. Now, these TKY kind of joints, usually you see them everywhere. We see them in oil and gas, we see them in automobile, in infrastructures, shipbuilding, everywhere. It's in a part of life. So how do we make sure that these joints are safe and free of defects? So we got here something which will explain the process of inspection, and eventually I will also share some new tools in the ever-growing industry of ultrasonics, which could be used to make these inspection a little bit lesser challenging than as it was in the past. So to start with, when we perform an ultrasonic inspection, certain rules related to ultrasonics are always applied here. Now, these rules are reflection and refraction. So basically, you send a sound inside a material, and what it does is whenever it comes across a defect, it would reflect back. Okay, now whatever energy reflects back, we catch that, and then we say that, okay, there is something wrong in the integrity of this particular component, and we need to see that. And when it comes to weld inspection, what we typically do here is we make sure that we send the ultrasonic energy at a particular angle. And this angle basically is targeted one of the weaker areas in the weld, or areas which are suspected to have flaws and which are not supposed to be there. So we do that. But then what usually happens is sometimes when the geometry of the component that we try to inspect, if it is not flat, if it's a bit different than usual, it becomes a little bit of challenging to understand where the ultrasonic energy is going after it reflects from a particular area where it goes. To understand that, or to anticipate that, it's a bit of challenge. It needs a bit of skill. It needs quite a lot of experience. And then there can be other challenges, like you may not have access to the weld where you want to. So you might have to keep the sensor at a different place. You don't have place to keep the sensors there. So what we do is basically we come up with some new techniques, and these techniques can be implemented or should be implemented. Now, one of the examples is shown in these images. If you see the image, which is on the bottom left of my screen. So here you can see that the defects are not in the usual area. Okay, so what we do, we basically use two transducers sometimes, and we make sure that we detect them. So this is generally ultrasonics, and these are all related to components which we call as butt joints. So basically two plates welded together. Now this can be there can be also some changes in the geometry. Like one of the examples here is when we build a pressure vessel or a boiler, for example, there is a shell component and a dome component. Now the thickness between these two components are different, and there can be some tapers. So what usually happens is we need to make sure that the geometry that we are going to inspect, we know that well. We know how the weld is prepared, etc. Now, once we know this, what we typically do is we prepare something called a scan plan. And when we build this scan plan, what do? What we do is we look for nominal geometries which are supposed to come from the weld. Now, one of these nominal geometry is the root indication that you can see here, and then the top indication, which you can see here. If these two geometries appear, we know that the way the ultrasonics propagating into the material, into the weld, is correct. Now, this can be difficult if the thickness varies and if there is a taper. Now, to understand these, what we have done is we have introduced some tools like importing of a CAD file in the system that is being used to perform these kind of ultrasonic inspection. Now, when you import this, you generally get a rough idea, or you already know that, okay, my ultrasonic beam should use these rules in physics and should be hitting certain areas. So for an operator who is less experienced, less skilled, probably, he can quickly come to a conclusion that, okay, this is what I'm going to use, provided we have a good CAD drawing that we can use. Now, let's jump into TKY, how it helps us to give a better TKY result. Now, TKY basically is a joint which looks more or less like this, the example that you see on my screen image right now. Now, what we do is basically we take two pieces of metal and then we perpendicularly weld them. Now, there are different ways you can weld them, okay? There can be some angles given. And what usually happens is if these fusion areas that we are looking at, if they're not properly fused, this can really go into a major disaster. It can fail the component, it can fail the structure, and eventually lead to loss. So what do? First of all, we understand the geometry, how the welding is performed, what angle is used in order to make sure that the weld is properly done, etc. Now, once we know that, which is generally we know because every welding that is performed, usually there is a drawing somewhere, someone has a drawing, and the welding engineers, basically, they know how the welding process has taken place. So what we do is basically we take this drawing, we make sure that the whole weld area is properly covered, and the scan plan, which we call as a scan plan, is being followed while the inspection is performed. Okay, now, which really leads to a lot of signals coming from different areas. Now, in the butt weld, you saw that we get a reflection at the bottom of the weld, we get a reflection at the top of the weld. But then here, there are so many other factors, and the reflection can come from different areas. So it can become a little bit more complex. Now, what do? We use software, okay? And at the moment, people use an external software. This software tells that you have to keep the probe here, the sensor here, you have to send the ultrasonic energy in this particular fashion, etc. And universal probes. So basically, general purpose probes are used. And most often of the time, the component or the overlay that we use to make sure whatever data we have collected and whatever signals we are receiving, to overlay that signals on a component, we usually use something called a 2D overlay. And this 2D overlay is not really up to the mark in these days because it can be a different one. It's a modified one. There can be a lot of differences. So what we have done is we have come up with some new tools to overcome these challenges, and let's see what these tools are. So our software basically has the capability to draw these kind of weld joints, different types of weld joints. And not only different types of weld joints, we can also import CAD files like this. So basically, here is a T, you keep the probe here, and you send ultrasonic energy like this, the red areas that you can see here. And these will calculate the rebound patterns coming from different surfaces, whether it's an angle, whether it's a straight, etc., etc. Okay, it quickly helps us to build a setup which is far more precise than what used to happen in the past. And then with this, what we can also do is we can quickly make a scan plan. Now, here is an example. So this is a T joint here, and these are the welds that we wish to inspect. So what we typically do, we keep a probe here, we send ultrasonic energy like this, the green ones that you see, and to see the fusions here, we can send the ultrasonic energy like this. Now, this is one of the benefits of using PAUT. You can actually train the angles from the same probe to go in different directions. And eventually the results are quite amazing. So here you can see when the weld is intact, when there is no defects in the weld, if the fusion is nice, then you would not get any signal, or you're not supposed to get any signal in the welding area, as you can see here on the bottom left image, the second image on the bottom left. Now, if there is some indication, if the fusion is not proper, the sound will reflect and you would get some image. Now, this really helps the operator to quickly decide that, okay, look, something is wrong in this particular weld. There are some signals coming which is not supposed to be there. And the same thing we can do for an angle. We can send the beams in angle and we can pick if there is any sort of fusion indication here. So really simple setup, faster analysis, and we detect the critical areas within the weld. Now, here is an example too. Always, we do not have the opportunity to keep the probe at this particular point. So what we do is we keep the probe wherever it is possible, and we try to train the ultrasonic energy to go or to propagate in such a fashion that it covers the critical areas that we wish to inspect. Okay, and you can also position them in different locations. If this is also not possible, you can do it the other way around. Now, all this actually can be done because we are actually putting the right drawings, the right welding configuration, the right geometry in the system, and develop a setup which is far more superior than what usually been done. So with the help of this, if you see here, the image which is on the left hand side, basically this is coming from what is currently happening. So you get some indications here at the bottom, and you really don't know because it is coming from somewhere else within the weld. But actually what's happening is inside the part, the ultrasonic energy rebounds and actually picks something here inside the weld. So this indication could have easily been missed if you are doing the conventional way. While using the right tools, you can now really predict what is happening there. And a quicker analysis, I would say. Okay, so it's not just the setup that is created well, but also analysis and inspection is being performed with far more accuracy now. So these are some examples. Here we can see with the help of the rebounds, we can see some fusion areas here, which is not properly fused. We can also see some indication in the root areas here. And definitely these other things, these other images that you see, basically, these are geometries. These are the weld crowns, which have to be there. Okay, so we detect them. Usually you should not see any signal here. We are seeing that means there is a defect here. So it really simplifies and it helps us to make sure that the rebounds are well accounted, no matter how the surface is, how challenging the job can be. Everything here comes from the drawing of the welding that was carried out, and eventually we make sure that this drawing is properly implemented. And you don't need an additional software here, because the software itself that is used in the inspection, it is capable to handle these kind of geometries. Now, with the help of this, we can actually pick up indications, as you can see. So we had some sample plate and we tried to do some inspection here. And there is a defect over here, which is a tear basically. And this can be seen pretty much clearly here. So we send ultrasonic like this and we pick it up here. And these are different images which helps us to differentiate between the known geometries which are supposed to come and those indications which are not supposed to be there. So here in the root area, there is a big defect, and you can really see that. And usually, if we don't have a setup which is something like this, missing this defect is very easy. You can really miss them, and eventually you can also make a false call. Maybe it's a defect, but maybe you can think that it's a geometry. So benefits of these tools, basically, the complete geometry is taken into account. So we make sure that the welding process, the way two components are welded, everything is taken into account, and rebounds from different areas are basically considered. Everything is on board. So the equipment that you would use, the software is inbuilt in the equipment, and you can prepare the complete setup from the same equipment that you're going to use on the field to do this inspection. We can also make sure that 100% coverage, the weld is completely inspected by positioning the probe at different areas and simulating the scenarios that would come and how the ultrasonic energy is going to propagate into the welding. And also, with the help of this software, with the help of the drawing, we know where to position the correct place, where to position this the sensors, which has a crucial impact in the overall inspection. And eventually, with all the helps that we get from these tools, the analysis is simplified, which means if there is an indication, we'll know there is an indication. And the operator now, whether skilled, experienced, or not so skilled and not so experienced, can arrive at the same conclusion. All right. So basically, these are the benefits that comes with the with this particular tool, with this software upgrades. And I think I'm well in time with my presentation. So thank you very much. And if there are any questions, I would be happy to answer them.
Thank you, Vignesh, for your presentation. Very technical for me to understand. But in short, in your current projects and current workplace, what are the challenges you see which people ignore?
So basically, what happens is it's all about the awareness. Right now, we are growing at a very fast pace. Okay, people sometimes they use those tools which are typically a bit outdated. Okay. With the development in the software and the way we have prepared the algorithms, etc., what we can really do is now there are tools available to inspect those areas which were considered impossible in the past. Okay, and also in a much simpler fashion. So this is one of the challenges because people are not yet up to speed with how much growth in the technology has happened. And when they see this, their first impression is, oh, that's amazing, that's wonderful, and it's quick. People can adopt to this very quickly, which people are doing. I mean, industry is really at a very fast pace, looking for new things, new tools to make their life simple. So I would say the challenge is just we need to speak to more people. We need to actually attend a lot more events like this and share whatever we can. So that's what.
And among your GCC countries or Middle East, where did you all start first your projects and things like that?
So basically, we are manufacturers. So we manufacture these tools, and these tools are being implemented on field by our customers who are into the mainstream service industry. For us, our systems are currently deployed more or less globally. So we can say that people are using these systems within, if we speak about GCC, people are using it in Saudi Arabia, people are using it in Kuwait, Aramco facilities, a lot in PDO facilities, etc. also. So it's pretty much global within. So Edify basically acquired a company who built this system 3 years ago. 3 years ago, we hardly had a few systems in the market, but now I think we have more than 30 or 40 systems currently live and being operated.
Excellent. Thank you, Vignesh, for your time, and hope
Thanks,
to meet you
Melvin.
in our next event.
Thank you. See you soon.
Have a nice day. Bye-bye.